Title: What is an elevator ARD and how does it work during a power failure? Hook: What happens if an elevator loses power while passengers are inside? Many people assume the answer is simple: use a backup battery, but in modern elevator systems, passenger rescue during a power failure is not just about backup power, it is about controlled emergency operation. That is where an elevator ARD becomes important. ARD stands for Automatic Rescue Device, or Automatic Rescue Operation Device. Its job is to help move the elevator to a safe landing during a power interruption, open the doors, and allow passengers to exit safely. But a modern ARD does much more than supply emergency power. It coordinates elevator movement, leveling, door opening, and passenger release. Why power failure response matters: in a small low-rise building, an elevator outage may be temporary and manageable, but in high-rise buildings, hospitals, hotels, airports, transportation hubs, and commercial buildings, elevator stoppage can quickly create serious problems. Passengers may become trapped between floors, lobby congestion may increase, elderly passengers, disabled users, or hospital patients may face accessibility problems. Emergency teams may also experience more pressure if several elevators stop at the same time. This is why elevator emergency rescue systems are an important part of modern building operation. A power failure is not only an electrical problem, it is a passenger safety and building management problem. What an ARD actually does: a common misunderstanding is that ARD is just a backup battery. That is not accurate. An ARD does not try to keep the elevator operating normally during an outage. Normal elevator operation is about transportation efficiency. ARD rescue mode is about controlled passenger evacuation. When a power interruption occurs, the ARD system follows a rescue sequence. First, it detects the power failure. Modern systems usually wait for a short confirmation delay, so they do not activate unnecessarily. During a very brief voltage dip second, the system isolates the normal power supply. This helps prevent unstable interaction between the main supply and emergency power. Third, the emergency power source is activated. This may involve batteries, emergency inverter coordination, UPS, assisted circuits, or backup switching modules, depending on the elevator design. Fourth, the elevator moves at controlled low speed toward a safe landing. Fifth, the system verifies leveling. Finally, the doors open so passengers can exit. So the key point is this: ARD is not only power backup, it is a rescue coordination system. Why ARD moves slowly? Some passengers may wonder, if people are trapped, why does the elevator move slowly during rescue? The reason is safety. During a power failure, the elevator is operating under abnormal electrical conditions. The system must manage traction control, brake coordination, motor behavior, and stopping accuracy with limited emergency power. In this situation, speed is not the priority. Control is the priority. Controlled low-speed movement helps reduce the risk of unstable motion, poor leveling, sudden stopping, or traction problems. Before the doors open, the elevator must reach a safe landing position. This is especially important for elderly passengers, wheelchair users, hospital stretchers, or passengers carrying luggage. A good ARD system does not rush the elevator. It moves the cabin carefully, verifies the landing position, and then releases passengers. ARD versus ARD is also often confused with UPS, or uninterruptible power supply, mainly provides temporary electrical continuity. It may keep selected circuits, controllers, or communication equipment powered during a short outage, but a UPS does not automatically manage elevator rescue movement. It does not necessarily move the cabin to a safe floor. It does not verify leveling. It does not decide when to open the doors. That is the role of ARD. A simple way to understand the differences: UPS supports power continuity. ARD coordinates passenger rescue. In some elevator systems, UPS equipment may support part of the emergency power architecture, but the rescue logic still depends on ARD coordination. Older elevators and modernization. ARD also matters in elevator modernization. Many older elevators were not originally designed with integrated emergency rescue systems. During a power outage, they may depend on manual rescue by maintenance personnel. That can take time, especially in busy buildings. Older systems may also have outdated relay controls, aging batteries, incompatible drives, limited cabinet space, or unstable rescue logic. Some elevators may work normally every day but still have hidden problems during actual rescue operation. That is why ARD compatibility should be evaluated early during modernization planning. It should not be treated as a small accessory added at the end. Maintenance and testing. An ARD system must also be tested regularly. If it is not inspected for a long time, Hidden problems may appear only during a real outage. Common risks include battery aging, delayed rescue activation, wiring degradation, relay failure, inaccurate leveling, or door opening problems. Routine testing should check battery condition, rescue activation timing, low speed movement stability, leveling accuracy, door opening sequence, and emergency control logic. A rescue system should be maintained before it is needed, not after passengers are trapped. Conclusion: an elevator ARD is not just backup power. It is a coordinated emergency rescue system. During a power interruption, it manages emergency power, controlled movement, leveling verification, door opening, and passenger release. For high-rise buildings, hotels, hospitals, airports, public buildings, and modernization projects, ARD is an important part of elevator safety and building resilience. For more details, you can read the full article here. https://EKCNE.com. What is elevator?